Hello everyone, this is Minsu Kim. In this presentation, we introduce about our work, Implicit Neural Image Stitching with Enhanced and Blended Feature Reconstruction. Previous deep image stitching of UDIS takes in warped images. After that, it reconstructs a stitched image from features encoded by CNN networks. Because their method automatically corrects color mismatches and blends misalignment in an inference, the approach provides intuitive image stitching, simplifying the previous pipeline of image composition. Despite the advantages, the previous deep image stitching shows unpleasant blurred image quality and artifacts, as indicated in the arrows. To address the limitation, we suggest an implicit neural image stitching that provides enhanced and blended feature construction. We divide training stages into one for learning enhanced representation and another for blended feature construction. The designed neural image stitching is provided here, consisting of a shared neural warping, a blender, and a decoder. Neural warping, colored with purple, learns dominant frequency of warped features. The blender, colored with yellow, stitches two features in a unified representation. And the decoder, colored with gray, decodes a feature vector to an RGB. In neural warping, it estimates Fourier coefficient for capturing high frequency details. This estimation of Fourier representation is inspired by the novel position encoding with local texture estimator. After the extraction of coefficients, neural warping associates Fourier representation with nearest neighbor warped coefficients. Then Blender unifies the associated warped features of target and reference images into a stitched representation. The decoder takes in sampled feature vectors and outputs the corresponding valid region RGBs. Comparisons to the existing methods are here. In the left qualitative comparisons, our method shows high-frequency detail-aware image stitching. In the right quantitative comparisons support the qualitative observation that our approach provides visually pleasing image stitching with least number of parameters than UDIS. This slide's comparison to bilinear with sim-cutting image stitching shows feasibility of NIS's multiple image stitching with sim-cutting. We simply apply the sim masks on the warped features and decode them to a stitched image. All the training samples of neural image stitching are under the homography warps. However, due to the property of implicit neural representation, neural image stitching can be generalized to elastic warps as below. However, when it stitches images exposed to very large parallax, it may construct ghosting artifacts struggling with lack of escaping method. Thank you for your attention.